Hello everyone, welcome back to StudyMation's Computer Science series. And today we'll be talking about the number systems. The basic building block in all computers is the binary number system. This system is chosen because it consists of ones and zeros. Since computer contains millions and millions of tiny switches, these millions and millions of tiny switches, which must be in the on or off position. So they can be represented by the binary system. A switch in the on position is represented by 1. A switch in the off position is represented by 0. Switches used in a computer make use of logic gates and are used to store and process data. First, let's talk about the Denary number system. We are all familiar with the Denary number system, which counts in multiples of 10. This gives us the well-known headings of units or place values, tens, hundreds, thousands, and so on. Denary uses 10 separate digits from 0 to 9. Denary thus has a base 10 number system, so it would have any number with the base 10. So this is Denary. We usually count in the Denary number system. Now the binary number system, which is the computer's way to understand um, orders and instructions, it has a base 2. Why does it have a base 2? Is because it uses numbers 0 and 1. So binary has a base 2. So any number with the base 2 will be considered a binary number. Like Denary has a place value of tens, hundreds, thousands, and so on, binary has the place values of the power of 2. So we would have 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so on. Now let's talk about the conversion from binary to denary. So in order to convert a binary number to decimal number or denary number, it is really important to memorize the powers of 2, which is 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, and 1024. So now let's convert an 8-bit binary number into a denary number. So our 8-bit binary number is 1, 1, 1, 0, 1, 1, 1, 0. So our 8-bit binary number is 1110110. We're going to convert this into a denary number. So in order to do that, we're going to multiply each number with the power of 2, starting from the power 2 to the power 0, starting from 2 to the power 0. So we're going to first start from the 0, from right to left. So now we would have 0 into 1, because 2 to the power 0 is 1. Then we would have 1 into 2, 1 into 4, 1 into 8, plus 0 into 16, plus 1 into 32, plus 1 into 64, and plus 1 into 128. Now, simply we know that any number multiplied by 0 would be 0, so we're going to just add those numbers, which are being multiplied by 1. So in this case, we have 2, 4, 8, 32, 64, and 128. So 2 plus 4 plus 8 plus 32 plus 64 and plus 128, and you would get the answer 238. So this binary number 1110110 is equivalent to the denary number 238. So this is how you convert any binary number into a denary number. So it can be an 8-bit binary number, it can be a 12-bit binary number, or it can be a 16-bit binary. The method would stay the same for any bits of binary. Now we're going to talk about conversion from denary to binary. So the method to convert any denary number into a binary number involves successive division by 2. So for example, our denary number is 142 and we need to convert that into a binary number. So first we're going to start off with making a ladder. Now we're going to write the number 142 on the top of the ladder and start by dividing the number by 2. So 2 71s is 142, which has a remainder 0. 71 cannot be divided by 2, but 2 35s is 70, so we're going to write that 2 35s is 70, but the remainder would be 1. Now, 35 divided by 2 cannot be possible, but we know that 2 17s are 34, so we're going to write 2 17s is 34. And now the remainder will be 1. 17 cannot be divided by 2, but we know 2 8s is 16, so 2 8s is 16, and our remainder will be 1. 8 can be divided by 2, so 2 4s is 8, remainder is 0. 4 can be divided by 2, so 2 2s is 4, remainder is 0. 2 1s is 2, remainder is 0. And now what we're going to do is divide that 1 by 2 as well. So 2 zeros is 1, and it would have a remainder of 1. So we need to do the successive division by 2 of the denary number, and we need to get that 0. So we're going to also be dividing that 1 by 2. Now what we're going to do is write these remainders from bottom to top. So in this case, we get 1, 0, 0, 0, 1, 1, 1, 0. So this is our binary number. So 142 is equivalent to the binary number 1000110. The binary value would have a base 2, and the denary value would have a base 10. So this is the method for converting any denary number into a binary number. Now let's talk about hexadecimal number system. So hexadecimal number system is very closely related to the binary number system. Hexadecimal, sometimes referred to as simply hex, is a base 16 system. So any number with a base 16 is a hexadecimal number. Why does it have the base 16? Is because it uses 16 different digits to represent each value. So it uses numbers 0 to 9 and A to F. So if you count that, it's a total of 16 digits, 16 values from 0 to 9 and A to F. So instead of writing 10, 11, 12, 13, 14, and 15, the hexadecimal number uses letters to represent 10 to 15. So the number 10 is represented by A, so the number 11 is represented by B, the number 12 is represented by C, and so on, so on. The headings for hexadecimal number is powers of 16. So we have 16 power 0, 16 power 1, 16 power 2, 16 power 3, and so on, so on. Since 16 is equals to 2 to the power of 4, this means that 4 binary digits are equivalent to each hexadecimal digit. So for example, the binary value 0001 is represented by 1. So 4 binary digits are equivalent to 1 hexadecimal value. The same goes for 0010, which is represented by 2 in hexadecimal value. So here's a table that summarizes the link between binary, hexadecimal, and denary value. Now let's talk about conversion from binary to hexadecimal. Converting from binary to hexadecimal is a fairly easy process. So for example, we have the number 1, 0, 1, 1, 1, 1, 1, 0, 0, 0, 0, and 1. So we're going to start off from the right and moving to the left. So from the right to left. What we're going to do first is split the binary numbers into groups of 4 bits. So we have 1, 0, 0, 0 is group 1, 0, 1, 1, 1 is group 2, and 1, 1, 0, 1 is group 3. You can even see that 1 group, 2 group, and 3 group. So there are a total of 3 groups that can be made from this binary number. So what we're going to do is we're going to write 8, 4, 2, 1 on top of each binary number. So 8, 4, 2, 1, 8, 4, 2, 1. Now we're going to see that the numbers above the ones are going to be added. So in the first group, the number above 1 is only 1. So this means that the first group is equivalent to 1. For the second group, we know that 8, 4, and 2 are above 1. So we're going to add 8, 4, and 2, and we're going to get is 14. For the last group, the numbers 8, 2, and 1 are above the number 1s. So we're going to add 8, 2, and 1, and we're going to get the number 11. Now, what we're going to do is we're going to, as we remember that we do not write 10, 11, 12, 13, 14, 15, but we represent them with letters instead, from A to F. So the number 11 and 14 is 10 or greater than 10. So what we're going to do is represent them by the letters. So for 11, we're going to be representing it by B. For 14, we're going to represent it by E. And 1 will be written as it is. So our answer will be BE1 with a base value of 16. Now this is our final answer. So the binary number 101111100001 is represented by BE1. Convert any binary number into a hexa number. But what if the numbers are an odd value? The binary numbers are in odd bits. For example, if we add another one before that number, we're going to see that our 1 would be left alone. So what would we do in that case? we will do in that case is write zeros following that number to make it a group of 4. So it doesn't matter if the number would be left alone, we can always add zeros, even if the number is 1 or 0, which is being left alone. We're going to just follow that by zeros, and we're going to write 8421 on the top, and of course we only add the number which is above the number 1. So we can see that the above the number 1 is 1 itself, so 1 will be our answer. So in that case, we would write 1. Since it's not equal or above 10, we're just going to write it as 1, and our answer in that case will be 1BE1 with the base 16. Now we're going to talk about the conversion of hexadecimal to binary number. So for example, we have a hexa value BF08. We're going to convert this hexa value into a binary number. In order to do that, first we're gonna write the letters into numbers. So we know that B is represented by 11. So we're gonna write 11. F is represented by 15. So we're gonna write 15. 0, we're gonna write as it is. 8, we're gonna write as it is. Now what we're going to do is again use the 8421 method. So 8421, 8421, 8421, 8421. Now what we're going to do is we're going to see what numbers from 8421 could be added to make the number that's above. So for example, we have the number 8. What numbers we could add from 8421 to make it 8? So 8 itself is already in 8421, so we don't need to add anything. We know that 8 is equivalent to 8. So what we're going to do is just write 1 underneath the value which we need to add or which we need to know. So what we're going to do is write the value 1 underneath 8 and follow that by 3 zeros because 4 to 1 would be zeros. So we can now see that the number above 1 is 8, and we know from our previous conversion that any number above 1 would be considered the value. So in this case, it's 8. The 1,000 is equivalent to 8 in hexadecimal value. Now for 0, we know that we will not add any number, and then we would have the equivalent to 0. So we're going to just write 4 zeros. So in here, no number is being added. In case of 15, we have to see that what numbers will we add to make it 15. So we know if we add 8, 4, 2, 1, we're going to get 15. So I'm going to write 1 underneath all of it. So we have 4 ones. So if we add 8, 4, 2, and 1, we're going to get 15. So 4 ones are equal to the value 15 in hexadecimal. What numbers we can add from 8421 to get the value 11? So we know if we add 8, 2, and 1, we're going to get the value 11. So I'm going to write 1, 1, 0, 1. Since we don't have to add 4, we're going to write 0 underneath that. But we have to add 8, 2, and 1, so I'm going to write 1, 1, 1. So what 0? Double 1. So these are the binary value to represent the numbers above. So 11 is represented by 1, 0, 1, 1. 15 is represented by 4 ones. 0 is represented by 4 zeros. 8 is represented by 1 followed by 3 zeros. Now if we put all these digits together, 1, 0, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 1, 0, 0, 0. So this is going to be our answer with the base 2. So BF08 hexadecimal value is equivalent to 1011111100001000 in binary form. To convert hexadecimal numbers into denary and from denary to hexadecimal, we can simply do is first convert the denary number into binary number and then binary to hexa. And we can also do that with hexa to denary. We can just convert hexa to binary and then binary into denary. Though there's another method to convert hexadecimal numbers into denary, which involves the value headings of each hexadecimal digit, which is the power of 16. And you can also convert from denary to hexadecimal, which involves successive division by 16 until the value 0 is reached. But these two methods are really hard, so the easier way is to convert the hexadecimal number to binary and then binary to denary, and in case of denary to binary and then binary to hexadecimal, which is much easier. So in that case, you can follow the same methods of conversion of denary to binary and hexa to binary and vice versa. And that's all for today. Thank you for watching Study Nation animated educational videos.